Let's try some examples. The standard normal model refers to a normal model with what mean and standard deviation? Well, in the standard normal model, we have a mean of 0 and a standard deviation of 1. The normal model with mean 64 and standard deviation 3 gives a good approximation of adult U.S. women heights in inches. What percentage of U.S. women would we expect to be taller than 61 inches? You should pause the video and try this on your own, and then come back and see if your answer agrees with mine. Okay, so if you tried this on your own, when you opened StatCrunch, you should have plugged in a mean of 64, a standard deviation of 3, and we want to know what percentage would be taller than 61, so we want to make sure we're on greater than or equal to 61, and then hit compute. Let's actually do that in StatCrunch. So here's StatCrunch. I'm going to go to Stat, Calculators, Normal. And we set a mean of 64, standard deviation of 3. And notice I want the greater than or equal to here. Greater than or equal to, what was it? 61. Let's compute. I get 0.841. Which was option B. What's the probability that a randomly selected U.S. woman is between 62 and 65 inches tall? Again, we're looking at the same distribution, so we're going to keep the mean and standard deviation. On StatCrunch, we're going to need to switch it to the between so that we have two lower bound and an upper bound. So 2 boxes to fill in. And I want between 62 and 65. So let's do that. Whoops. So I've got my StatCrunch window open still, so let's click between and let's adjust this to 62 to 65 and hit compute. I get 0.378, so my answer is B, 0.378. What height corresponds with the 90th percentile? So here, ooh, that's a bad picture. Let's fix that. Try again. So here, I'm looking at another normal curve. That's a very poorly drawn curve, but here it is with a mean of 64. I want to know what height corresponds with the 90th percentile. I'm looking for the height such that the area to the left of it is 90%. So 90% of the heights are below that height. So that means I know an area. 90% I'm going to convert to a decimal is 0.9. And I'm looking for what's the height that corresponds to that area. So my mean and standard deviation are going to remain the same. Mean of 64 and a standard deviation of 3. But now I know the probability, so I'm going to plug in 0.9. Now you should make sure that you are on less than or equal to, right? Because the area that we've shaded here is to the left, which corresponds to less than or equal to, okay? All right, and we're going to ask the calculator to give us this x value. Let's try that. So I'm going to go back to standard. I'm going to switch this to a less than or equal to, and I'm going to delete the 61 and plug in 0.9 here. Okay, so 67.84. So 90% of the heights are less than or equal to 67.84 inches. And that is going to give us option C. All right, let's look at just a standard normal curve. So remember, in the standard normal curve, we have a mean of 0 and a standard deviation of 1. That's a fact that you should know. What's the probability that a z-score will be 1.76 or less? So here I have a mean of 0 and a standard deviation of 1. I want the probability that a z-score will be 1.76 or less. So here's my 1.76. And if I want 1.76 or less, the area that I'm interested in is the area to the left, right? Less than. It's a big area to color. So all of this. All right, so I want to make sure that I have a less than or equal to here when I plug it into the calculator, and I'm going to put 1.76 in for my x value. I'm going to change my mean and standard deviation. Remember again, standard normal, the mean is 0, standard deviation is 1. I wanted the probability that x is less than or equal to 1.76. And that probability is 0.96. Now, the second part of that question asks what's the probability that x is greater than or equal to 1.76. So let's go ahead and do that here. I get 0.03, 4 when I round. 0.04 and 0.96. Let's write those in. So we got 0.96 and 0.04. Now, what do you notice about these two numbers? So 0.96 is this yellow shaded region here. 0.04 is the white region here, the part that's above 1.76. And if I were to add those two numbers together, what do I get? They add to 1. Now that shouldn't be surprising because this is a probability density curve, and the total area under a probability density curve is always 1. So in fact, if I knew that this yellow region was 0.96, without even going to the calculator, I could find this white region by just taking 1 minus 0.96 to get 0.04. All right. Let's look at another example. According to the National Vital Statistics, the average length of a newborn baby is 19.5 inches with a standard deviation of 0.9 inches. The distribution of lengths is approximately normal. What's the probability that a baby will have a length of 20.4 inches or more? Let's think about our picture here. So I have a normal distribution, poorly drawn, with a mean of 19.5 and a standard deviation of 0.9 inches. I want to know the probability that a baby will have a length of 20.4 inches or more. 20.4 is to the right. And if I want the probability that it's 20.4 or more, I'm going to shade the region to the right. Okay, so I want the probability that x is greater than or equal to 20.4. So I'm going to plug in a mean of 19.5, a standard deviation of 0.9, and I want x greater than or equal to 20.4. And you're going to hit compute. Let's do the other parts before finding the answers. In part B, I want the probability that a baby will have a length of 21.4 inches or more. I'm going to draw my same picture. I'm just moving up a little bit to 21.4 inches or more, and so I'm going to shade the area to the right of 21.4 also. So I'm going to plug in the same mean, 19.5, and the standard deviation of 0.9. And I want the probability that x is greater than or equal to 21.4. Part C wants to know the probability that the baby will be between 18 and 21 inches. Let me draw a whole new picture for that. Let's just use black. So here's my normal curve. I have a mean of 19.5. And I want to know what's the probability that we're between 18, which is to the left of my mean, and 21, which is to the right. And I would shade between those two numbers. Not very good shading. All right, so I would plug in 19.5 and 0.9 again for my mean and standard deviation. And now you want to make sure that you switch to the between so that you have a lower bound and an upper bound. And I'm going to put in 18 for my lower bound and 21 for my upper bound and hit compute. Now I'm going to let you compute those on your own. If you have trouble with that, please send me an email and I can help you or stop by office hours.